guys, what's up? I'm Soumyadeep again back with a new tutorial video. Today I'm discuss about normal stress and another is shear stress. So yesterday I'm discuss about sign convention of stress. So when is positive and when is negative, and also I discuss about what is denoted by tau xy, what denotes by x and what denotes by y. So hopefully you understood that video. If you not understand, so in there should be a I button, so click it. Otherwise do comment in comment section. So let's start with normal stress. So let's start with normal stress. In the word normal, when we hear the word normal, that is something which is related to perpendicular or 90 degree to each other something. So let's see what is the significance of the term normal. Look, the word stress already we know in the last video. So what is the normal stress? So we have to understand what is the meaning of normal. For understanding normal stress, first we have to draw a prismatic bar, which is this. So basically this is a prismatic bar. Okay, so yeah, what is the prismatic? You know, bar, this is bar, but what is prismatic? Prismatic denotes same cross section area throughout area, length. Okay, so the bar whose cross section area A throughout is constant, but if there is a bar like that, this is A, this is A also, but here the cross section is always changed. So in this case this is not a prismatic bar. So hopefully you understand what is prismatic bar. The prismatic bar is same cross section area throughout the length. Okay, force is acting this side. This is P, this is P. As I say, this is normal. So what is the significance the word normal? This is means that this particular force acting on the plane A with an angle of 90 degree. So if I draw it in a bigger manner, suppose this is a block, if for normal force or normal stress, if force is acting on this side and this side, so angle between this force and this cross section area is 90 degree. So that is the main significance, the word normal. Hopefully you get it. Okay, so let's forward. So the force is acting on two sides. Okay, now what I do, I cut the section. I cut the section from this manner. So what will be happen, guys? This thing happen. One side is this, so this portion is this, and this portion is this. So for this force, P is acting here, and this force P is acting there. So as I draw the free body diagram, so there must be some internal force which is resisting this force. So there generate sigma dA, sigma dA, sigma dA. In same manner, this side also generate sigma dA, sigma dA, sigma dA, sigma dA. You may say, sir, why sigma dA? Because stress is a tensor quantity. So this is a vector quantity, so we have to equalize vector to vector. So first we have to convert tensor to vector. That is why we multiply with area, then the stress tensor convert to the vector. I will discuss this particular why stress tensor in next video. So what happens is there, for equilibrium we can say integrate sigma dA or summation of sigma dA, both are same word, equal to P. So summation of sigma dA equal to sigma into area P. So sigma equal to P by A. So why summation of dA is the A? Small dA is very small area. So summation of the small area we get the full area. That is why I am saying summation of dA equal to A, capital area. So this is the our normal stress in axial loading on a prismatic bar. Okay, material is homogeneous. Point number 2, load must be passed through centroid. Okay, hopefully I know you everything know what is centroid. if you don't know about centroid or center of gravity, so do comment, then I will make a video about centroid. And point number 3, Saint Venant's principle is applicable. What is Saint Venant's principle? The difference between the effect of two different but statically equivalent loads become very small at sufficient large distance from the load. So this is a body, okay? If force is applied in this manner, then the force is, and it is the B and it is the D. If B less than D, then this force or stress due to this force is uniform in the D distance from the upper end. Here the sigma or no stress, whatever, is uniform. So these 3 is very important for normal stress. Now I move to the shear stress. So buddy, we read about normal stress, which is perpendicular. So again, this word stress is very common to us, very familiar with us. But what is shear? Shear means the stress is parallel to the cross section area. Yeah. So very simple. Tau equal to shear force per unit area, which is in nature 1 tangential, because this is the body, this is acting. So as this is a parallel, so this is kind of tangential. Well, so in our strength of material, shear stress in generally 2 types. One, single shear, and another is double shear. If anyone from the 3rd year diploma or final year BTech student, those who have do the steel structure, there is a word basically single shear, double shear. Very simple. What is single, what is double? If this is the 2 plates and this is the bolt connection and this is the gusset plate 1, this is the gusset plate 2, then you tell me now from where tearing is happen. Very common sense buddy, tearing happen from this side. So this is called single because tearing happens in a once, and double, make it double. 1 gusset plate, another gusset plate, and another gusset plate, and this is 1 bolt or rivet, whatever you say. This is P, this is P1, this is P2. Okay. So if again this force is this side, this side, for tearing is happen in which direction? 1 direction, 2 direction. So 1 and 2. That is why this is called double shear. So when I start the steel structure, then I tell you in detail, but for this is sufficient. So उम्मीद करूंगा ये वीडियो आपको पसंद आ गया. अगर पसंद आ गया तो प्यार दिखाओ, लाल बटन दबाओ, सब्सक्राइब कर लो यार. अगर if you like the video, then subscribe, and if is it helpful to you and your circle, so do share as much as possible because it's free. So अभी यही तक, गुड बाय. फिर मिलेंगे कोई एक नया कंसेप्ट के साथ कल.